Hi everyone, this is Tom. Nice to see you again. Today I'm going to do something a little different. Instead of showing you another Julia programming tips, I would like to share with you an exercise that I'm working on as related to natural language processing. In particular, as you can see on screen right now, this is regarding sentiment analysis using TextAnalysis.jl package. And the reason why I was doing that is because I am sort of participating in a weekly contest as part of being a member of the Humans of Julia Discord server. And just quickly to talk about it, I happen to be a moderator in that community as well. It's a very relatively small community, about 300 people. And we have a group of enthusiastic people who want to do something interesting every week. And so we're having a contest on a weekly basis. This is week 2, and we're working on TextAnalysis.jl. Basically, anyone can just use that package to do whatever they want with it. Okay, and so I happens to pick a data set from Kaggle. It contains data from Twitter as related to US airline sentiment data. And this is my first project using doing anything related to natural language processing, and I'm learning TextAnalysis.jl. So if you see anything that can be improved upon when you go through my notebook here, feel free to leave me a note on YouTube or just drop me a note on Slack or Twitter or even Discord if you're a member. So, and we can talk about it, okay? So today I'll just quickly go walk through the notebook and I'll share with you how I do the text processing as well as training a model to do prediction. Okay, so let's get started. All right. So with this notebook, I have basically downloaded the CSV file from Kaggle into this directory, and I have already activated the directory offline, as well as adding all the packages that I need. In particular, in this case, I need text analysis and all the data related packages. Loading the data is extremely simple. As you can see, it's just a CSV file, and I just load that into a data frame. Okay. And as usual, I would like to see some metadata, and just so I can understand the data better, right? So the describe function that you can see here, I'm showing just the element type, the number of records that I have missing data. And I just want to see the very first row of the data frame, so I'm putting in this special argument. It will basically run the first function on every column, which gives me the first value in that column, and it's showing me that value over here. So I can quickly see what the data might look like. Okay. And so as I was going through all these columns, there are a few ones that caught my attention, right? The airline sentiment, for example, it looks like is a label data that I'm looking for because we're looking at tweets, right? People are basically writing text, and that will be in the text column. It looks like when the data set was prepared, it already labeled the data in such a way that whether the sentiment for that particular airline is positive, negative, or neutral, right? Also, the second column here, airlines sentiment confidence, is also somewhat more interesting. It looks like numerical data. It has 1.0 in it. So my understanding is that maybe this number tells me how confident we have as related to this sentiment label. Okay, so for that reason, I have started doing some charting to understand that a little bit better. And interestingly, when I look at airline sentiments, you see a whole lot of records have negative label, which is probably not too surprising because if I'm writing some text on Twitter and I was mentioned about an airline, it's probably more likely that I am whining about that airline than I'm publicly appreciating about that airline. And I think that's just pretty regular human behavior. And when I want to look at the airline sentiment confidence, I would want to see what the values fall between. So I'm using a histogram here, right? So with the histogram, it's telling me that majority, in fact, a very large proportion of the sentiment labels, they have the value of 1.0, meaning that it seems to me that it would indicate that most of the labels are fairly accurate, right? Which is a good sign for us because we are going to be training our model, and we're going to be using those labels so that we can gain more confidence about our own model. Okay. Lastly, I want to see some context. So in this case, I would be looking at the negative reasons field, and I want to see what kind of reason why people don't like about a specific airline. And as you can see here, it could be customer service issue or late flight or canceled flight or whatever, right? So there are a number of issues. This is really just from my own understanding about the data sets, nothing to do with the model at the moment. So the whole data set has about 14,000 tweets, and I would like to see some of the tweets manually just so I can get a better understanding about how the text is being structured and what the record looks like, etc. So Pluto has a interesting feature where you can make some of the cells interactive. So I'm going to make use of that feature today. But one thing that I wanted to do is that when I look at a single record, I want to see the fields in rows rather than in columns, so I don't have to scroll back and forth, left and right. And in order to do that, I create a table function here that takes a name tuple, or it can take in fact, it doesn't have to be a name tuple. It could be a dictionary or anything that's indexable by keys. As you can see here, so just picking up the keys. And it will just put that into a name value pair markdown format. So when it is in markdown, then Pluto would know how to render the table. The next thing that I wanted to do is to bind a Julia variable to a HTML tag. In this case, it will be range input type, which will give me this slider going from 1 to 100, right? As you can see in these HTML attributes. What's good about it is that now I can actually slide over here, and I'll see another record immediately. I can go back just like that. So this allows me to quickly examine the data without having to requery the data frame over and over again. Okay. So as I was examining these tweets, one thing that I realized is that a lot of the tweets, they have these mentions which start with an @ sign, and also hashtags which start with the hash sign. And sometimes they have URLs just like that. These are somewhat problematic because they do not really convey any sentiment per se, right? Because if I am mentioning someone, then just mentioning the ID, it just doesn't really tell me whether it's a positive or negative sentiment. So realistically, I don't really want the mention to be in there, right? Because otherwise it would muddy up the water. Similarly with the hashtag, a lot of times the hashtag doesn't tell you anything about the sentiment. Although sometimes it does, but it's really, really, really difficult to really judge whether it matters or not matter. So for that reason, I think I don't really want hashtag to be used as part of the training exercise. The URL definitely doesn't do anything with the sentiment, so I don't really want it. If we don't do anything with these mentions and hashtags and the URLs, it could become a disaster, as you can see here. Because when I try to do some extra processing with the text later on, I might be stripping away punctuations or stop words or HTML tags, like how you see it here. And when I do that, you will see, for example, the mention became a real word, but I mean, it wasn't really part of what the user wanted to say, right? And likewise with the hashtag they're here. And so this is really not a good thing to have. What I wanted to do though is to actually remove them, right? And so this idea came from Jose when I happened to ask a question on Slack. So thank you very much, Jose, if you happen to be watching this video. Um, so what I wanted to do is to um, declare some of these regular expressions in such a way that I can either extract the particular special token, extract them out of to a different variable, or I can remove them as I want to, right? So for that reason, I have created two extra functions. One's called extract tokens, and all it does is that it will find every match that matches that particular regular expression, and then it will put everything up into an array. And the remove token function will take a string, and then it will go through all the regular expressions that we set up related to mentions and hashtags and URLs, and we'll just replace them with empty string, right? So this effectively will remove any mentions and any hashtags and any URLs from the string. So now with these extra tools, I can create a brand new data frame. And at this point, I just want to think all the fields that I like to keep, right? So I have the airline sentiment, I have the text that came from the original data frame, and I will start extracting the mentions and hashtags and URLs into separate columns. And finally, I have a clean text column, which basically we've got all those extra special tokens removed, as well as the whole thing got lowercase, right? So with the clean text column is pretty much what I want to continue down with the training exercise. As you can see here, record 36 now got mentions and hashtags and URLs all separate. And the clean text is left with a more reasonable text that we can do further processing. So now with this df2 data frame, I'm going to go on and train my classifier. And TextAnalysis.jl actually come with a classifier called naive Bayes, and it's a very basic classifier, but it can be very powerful. So today I will just use this to verify how I can do prediction using this naive Bayes classifier. Okay. And so to do that, I actually need to fit the model. And before I do that, I just want to do one more step in preparing the text, right? You saw the similar code earlier, but basically I would like to create a string document from the string itself. And I will take away all the punctuations and stop words and HTML text. And maybe there are other things I want to do, but right now I just want to focus on these three main ones. And the prepare bank function basically apply all those operations on the string document. And the stem bank function will take away some of the endings in an English word. For example, if I have a word that says reading, right? reading, the ing part doesn't really add anything, doesn't add any much context to the analysis that I'm working on. So it will become read rather than reading, right? So that's what stemming means. And so having that create string doc function, now I can start training the naive Bayes classifier. And the first thing that I need to do is to know what kind of classes that I'm predicting, right? So because they are all in this airline sentiment column, I just take the unique values out of it, and classes happen to be just positive, negative, or neutral. And the naive Bayes classifier basically needs to be created using those classes. And once I created that NBC naive Bayes classifier object, I can start fitting data into the model. And the way that I can do it is to take the clean text from the DF2 data frames and also the label, the airline sentiment. And then I'll create a string document from the clean text field, and I'll call the feedback function to fit that string document for that specific label into that model, right? Because we have 14,000 brackets, it takes a little bit time. You can see here that it took me almost like a minute. Plus my laptop is not very fast, so it took a while. So anyways, so after that, I will have a model that comes back that I can use for prediction, okay? Now, here comes the fun part. In order to do the prediction, right, I'll take the model, and I have this just utility function that I can take an array of tweets, basically an array of strings, and I'll create a data frame with those tweets. I will create a string document out of the tweets, and I'll do prediction on it. And the prediction will come back for every single class. It will come back with a probability for that class. And so I'll basically keep track of all those values, all those probabilities in separate columns in the data frame. In the end, when I run something like this, right, I wanted to test the model with my tweets that says, whatever airlines sucks, right? And that should be very negative. And I can see that the negative column is 0.85, which is pretty good. And the second one, I love American surfers. It has to be very positive, right? So this is what it says over there as well. And the third and the fourth one are kind of neutral, right? As you can see, it's just okay. And hello world, just okay with slightly positive, and that's why you can see 0.46 over there. So this classifier seems to work just fine, right? I'm pretty happy with it with just those 4 brackets. But how well does it work with the original data sets with 14,000 tweets, right? And so let's try to measure the accuracy over there. And over here, I have a predict and choose function. I'll take the classifier, and I'll take one string document. I'll predict it, and I'll return the label for that. Okay, and so with that special function, now I can choose between positive, negative, or neutral. I can call that upon the model with all the string documents coming from the clean text. Actually, don't need to do that. But anyway, so I could have used a clean text variable, but here I'm just using text and removing tokens and lowercasing again. But that's okay. It's really the same thing. Anyways, so y hat is usually what machine learning practitioners, they use it for representing something that's coming out from a prediction. Okay, and so as you can see here, 12,000 records were predicted correctly because I was comparing y hat with the airline sentiment column, and 2,536 records missed. Okay, just take a quick glance at it. It looks pretty good to me, right? There's like out of 14,000 tweets, I got 12,000 right. And in this case, I also want to look at what are the misses that are actually way off. By my definition of way off means that if I predicted something to be positive, but the actual label is negative, or vice versa, then it's way off, right? Because they're just completely different direction. However, if either what I predicted is neutral, or maybe the actual label is neutral, then we may be just slightly off, right? Because sometimes the probability will be very close and just happen to pick the wrong side. So in that case, maybe it's not that bad. And that's the reason why I measure way off in this case. And luckily, way off is only 733 here out of the 2,536. So So it seems that a lot of times we're not too much off, right? But anyways, to measure the accuracy, we need to look at number of hits divided by the total number of records. And so looks like we got 82% accuracy. For naive Bayes classification, I would think that's pretty good. But you guys who has done much more natural language processing than me, you can comment and tell me whether this is a good, accurate result or not. Okay. Anyways, slightly off percentage is 12%, and the way off is 5%. Okay, and you can see clearly from this bar chart, how they compare. So, just for fun, the last part I'm trying to analyze some random tweets. Okay, so Twitter has an API which is really easy to use. So I signed up for it, and I don't even need to use any package. I just use HTTP over here, and all I need to do is to hit the RESTful URL with a particular query, and then it will return back with a JSON document. With the JSON document, I can see the text in those tweets. So for example here, I am actually querying something with the word flight in it. Okay, and here is basically saying that I want to query only tweets that are in English. ENs mean English. And so it comes back with 15 tweets, in this case, maybe 14. And I can basically take these tweets and put into the naive Bayes classifier, and it tells me whether it's positive, negative, or neutral. And so this is exactly what I did. I run the test model function with the new tweets, and the tweets are basically the text that's coming back from this Twitter API. And so I can now see how good they are, right? For example, listening to robots by flight of the Concords and thinking about them. Okay. Not so sure about that. Maybe neutral. Yeah, that's more like neutral according to the classifier. The second record is very positive. Let's see what it says. A deeply personal story. Despite the social canvas, it flies high on the field of emotion. Okay, I guess when it says it flies high, somehow it predicted that it's positive. Okay, so anyway, so I'm having a little fun with this prediction, but you get the point. Now that we have a classifier, we got a model, we can look at tweets and then do any type of prediction. One thing I want to say is that because my training data all came from airline sentiment, if I take this model and try to predict something unrelated to airlines, I might get results that are way off. So I don't expect a lot of accuracy if I'm just use it to do sentiment analysis for anything else other than something related to airlines. So that might be the drawback, but I only have 14,000 tweets. There are much larger model out there that is already pre-trained and has seen a lot of different contexts, and so those models would be much better than mine. Okay. Anyways, I keep talking. I'm done for the day. Thank you for watching. I'll see you next time. Bye.